My name is Tim Cutler, and I'm the Director of Business Development for RFM's module and M2M products. And I'm going to take the next hour and kind of give you an overview of the different products that RFM has in the module category. So just a little bit, you probably are familiar with RFM. They're over 25 years. In fact, I think this will be RFM's 30th year. They came out of Texas Instruments to commercialize SAW filter technology. They started out with just filters and then grew into resonators, as you can see, the frequency control products, moving up to low power transceivers with the virtual wire products, and then RFICs. As they moved up the food chain, if you will, to more sophisticated transmitters, they looked around for a way to get into the higher end of the market, which is excuse me, the market that Serenet, which the companies I've been with for 13 years, was operating. So Serenet, we have over 20 years of, as you can see, ISM band or license-free module and box products, both proprietary and standards-based. Now we no longer use the Serenet brand. Everything is branded now as RFM. So some of the core competencies that RFM brings to the module, and again, these are certified modules in terms of FCC, Industry Canada, and ETSI as appropriate. Through our 20 years of experience is radios that simply work better than other radios. It's a challenge to me as a marketer to try and convey in bullet points what it is our modules have that don't really show up on a data sheet if you're looking simply at specs that have our excuse me, our modules work better. Now part of what that is just simply our understanding of how radio waves work in terms of interference and multipath, and that gets really accomplished through the real-time firmware that we have in our modules. Now all our modules are fully programmed, so there's no need for anyone to do any radio programming for our modules. We have some where they can do that if wanted, but these are fully programmed. They're ready to go. We do have our MAC protocol, which is patented, and again, that's where some of the experience that we've had over the past 20 years is really embodied in terms of what do you do beyond simply frequency hopping or the 802.15.4 or 802.11 to mitigate interference, multipath fading, things of that nature. Excuse me. So the result is that we have, very cost-effective products that deliver a lot of value. And then what we couple onto that, which is as important, is very good, thorough, and responsive tech support. So where some people are using forums or simply only email, we have both email and phone support. Our tech support works with our engineering group. They have direct access there, so you're not getting someone who simply reads a manual. If there are questions, they can actually go talk to the actual designers of the product. So the result is you get radios that work well, and as customers are doing the embedding, they're going to get good, timely support for any questions that they may have. So if we look at the different module families that we have our WIT, which originally stood for Wireless Industrial Transceiver, although they're not really necessarily industrial. And this is our high-end Cadillac, top-of-the-line, really just the best performing radios, I think, on the market. They're a little bit more expensive, though. So as over time we've ridden kind of the cost curve down the technology and have brought out our D&T, which are lower cost, frequency hopping, proprietary radios. We also have our ZPM family, which is our ZigBee Pro, our WSN, which is our sleeping Wi-Fi or 802.11, our LPR, which is the 802.15.4, which is really the same radio technology as ZigBee but without the meshing. and then our XDM, which is our WirelessHart, using products from Dust Networks. And we'll go through each of these throughout the presentation. The first slide here is a positioning slide, and let me explain what you're seeing here. So this 1K price, this is a resale price, and it's not the price, it's just kind of the dividing line. So in our 900 megahertz frequency hopping products, at the high end are our widths, and there for 1,000 pieces the resale is going to be $90 or more. All right, we look at our DNT 900, and at 1,000 pieces it's going to be less than $55. And then if we look at our DNT 90, it's actually going to be less than $35. The list price is $29, so at 1,000 pieces it's going to be lower. But this is a fairly convenient grouping of our modules. So again, you can see that our widths are our high-performance, high-end products. They're proprietary frequency hopping spread spectrum. That's what the FHSS stands for, in both 900 megahertz and 2.4 gigahertz. Then we have our DNT 900 and 2400, which is our mid-range frequency hopping radios. And then we have our DNT 90 and the recently introduced DNT 24. So you can see this DNT 24, we have 1, 2, 3, 4, 5, 6. And actually there's another width we discontinued a few years ago. So it's our 7th generation 2.4 gigahertz frequency hopping radio. So we have an awful lot of experience in designing these radios. If we come over to the right side with the green, our standards base, we have the 802.15.4 and ZigBee, Wi-Fi, and the WirelessHart. So the first thing you can see is that the WirelessHart falls into the high category. So it's a neat technology, but it's fairly expensive technology. All the others, the standards, fall into the low price point category. So whether it's our 802.15.4, our ZigBee standard feature set, our ZigBee Pro, or our Wi-Fi, they're going to be in the low-cost category. So now let's take a look at the markets that we sell these modules into. And I just have one listing of this because all of these modules can serve some piece or portion of these markets. And these are the ones that are getting a lot of attention in the press, with energy management, smart energy, wireless sensor networks, access control, security applications, whether it's badge readers or perimeter detection, asset tracking of all sorts, whether it's a simple single good or pallet of goods, commercial monitoring and control, and that can be energy consumption, it can be foot traffic, it can be any number of items. Cold chain and food safety, knowing where not just that the food has been at the proper temperature, whether it's hot or cold, but that it's been there through the entire time. And if it did fail on temperature, then you know where it happened. Electronic signs and athletic scoreboards, environmental monitoring, and then SCADA, which is supervisory control and data acquisition. And this is where you get into a lot of PLCs in the water, wastewater market, as well as any number of kind of process control, and then the healthcare and the home healthcare market as well. So all of these markets are served by these radio modules that we have. So if we look at the WIT family, and I'm not going to spend a lot of time here because this is, as you can see, these prices start at anywhere from $125 to up to $450. So these are really well targeted for high value verticals. But they're the same footprint, and we have 900 and 2.4. The power goes up to 1 watt for 900 megahertz, up to 100 milliwatts for 2.4. Data rates vary between the different modules from 172 kilobits per second to actually up to 1.2 megabits per second. It's one of the fastest hoppers out there. Like I said, we talk about high value applications. It's a UART interface. So there's a single interface, and you're going to send data to it serially, and data is going to come out serially. And we actually have Ethernet access points available. Now, if you look at these modules, this module right here is about the size of a business card. So they're fairly compact modules. So if you look at WIT, the value proposition is just as very high reliability and robustness. So we have them that they'll go from a few tens of meters to a few tens of kilometers with a variety of data rates. So widths are used when high data reliability is required. So this is not you're going to spend a couple $100 for a link. So the data you're sending, getting it from point A to point B, that has to be very valuable. For operation in really difficult RF environments, I tell people I've never really had someone tell me that WIT radios would not work. I've had a lot of people tell me they're too expensive, but they'll work. So if the most robust radio out there are the WITs. And where you need some longer range and then guaranteed bandwidth, and that's accomplished through a time division multiple access scheme that's an automatic scheme that makes it very simple. So why do WITs win some sockets? Because it's really the highest performance in terms of robustness and reliability among frequency hopping spread spectrum radios. They're also very configurable in terms of being able to configure how fast they hop. A lot of very sophisticated networking features. We have subbands and international bands so that they're easy to implement around the world. We actually have what we call Wi-Fi avoidance bands. A lot of people are concerned that frequency hopping, I'll say it, well, a lot. Some people were concerned early on that frequency hopping would interfere with their Wi-Fi networks. And so we can avoid channel 1, 2, 3, 1, 6, 11, whatever, and we'll hop in all the rest of the band, but we overcome that concern about hoppers interfering with Wi-Fi. And then they work where others won't. We've had a number of customers who've tried other products, and they come back and say, yours is the only radio that works. But again, the price point is going to make it for very high value applications. Now we're going to move on to the D&T family, and we kind of call the D&T 900 and the D&T 2400 our big D&T family. They're not very big. They're smaller than the width, so it's 1 1/4 by about 2 inches. So very compact size, both in 900 megahertz and 2.4 gigahertz. And these actually have variable data rates. So they're 4 over-the-air data rates from 38.4 kilobits per second, 115.2 kilobits per second, 200 kilobits per second, 500 kilobits per second. And then variable power levels from 1 milliwatt to 1 watt for 900 megahertz, and 1 milliwatt to 100 milliwatts for the 2.4. And the reason we stop at 100 milliwatts for the 2.4 is one of the values of 2.4 is it's available for use worldwide. But if you're using it in Europe, in the European countries, you can only go to 100 milliwatts. So we stop, we stop at that point. I'm getting into kind of some speeds and feeds here. I should tell you that you'll have access to this presentation afterwards, so you'll be able to refer back to some of these numbers if they're important. But what we've done with the D&T family is now we've added analog and digital I/O and a SPI port. So we still have the UART, but we've added the SPI port, which allows it to be embedded with lower cost micros that only have maybe a single UART, and if that needs to be used for something else. And then we have analog and digital I/O, so you can connect this directly to sensors, switches, outputs, things like that, and not have to create a serial language a command language that another coprocessor then will turn into the I/O. You can manipulate the I/O directly either through the local serial port or over the air from other modules. Then we have auto reporting and sleep modes. So you can actually put the radio to sleep, which puts it into a lower power consumption. But then you can also, excuse me, you can also configure it to on either time or interrupt or analog voltage basis to wake up and transmit its data. So now this is a nice feature to have because now you have an application that doesn't have to sit there and go around and poll all of the nodes. The nodes are going to auto-report on whatever situation it's configured to do. So it's a very powerful feature for the radio, particularly with the analog and digital I/O. So now you have the ability to create a wireless sensor node that doesn't require any other intelligence. All the intelligence is in the radio module. We also have encryption, which is the AES-128 encryption, and also authentication. Now what the authentication does is you have the ability to load in the radio itself 16 radio serial numbers, and only those serial numbers will be allowed to join the network. And if you have more than 16 nodes in your network, the radio will can be configured to output an authentication request to your application, where you can say, hey, a radio with this serial number has requested to join the network. Should we allow it? And the application can have a longer range of serial numbers and say yes they can join, or no they can't. It also has tree routing. So tree routing is a quasi-mesh. It's the same mesh technology that ZigBee uses, as a matter of fact. It's tree routing where there is a hierarchical basis to the network. You have specific routing nodes and leaf nodes, and then a network base or coordinator. But it does allow you to extend the range, and it does it in a more efficient way than, say, a store and forward routing scheme where you have a certain number of nodes that are simply repeating everything they hear. This is really kind of unicast all the way through the network. There's a second diagnostic port, and this is important because if you have an application where you want to monitor the health of the network, you can do that without that diagnostic information being embedded with the application data. So you just simply have a separate UART where all anything that's coming out of that is the diagnostic data. So you can have a diagnostic utility that only does diagnostics, and then your application only deals with the application data. So a very easy and straightforward way to get real-time network health information without complicating the application. It has over-the-air programmability, so we don't upgrade the firmware very often, but if there's a new feature we bring out that you want to add to units in the field, you're able to do that over the air, so you don't have to send someone out to each node to be able to reprogram it. And the network really is the number of remotes is limited by the amount of data you really want to send, but there's no logical limit to the number of nodes. You can have very large networks. And then the list price is only $69. So if you look at the value proposition here, is just unsurpassed flexibility. It's a frequency hopping radio, and at $69, it's less than half the price of earlier products. It competes, and you'll see this in a minute, with some radios that are selling for $150. So the D&T, the big D&Ts, where do you use those? When they want frequency hopping performance. When do you want frequency hopping? That's when you have interference and multipath concerns. When multiple applications are being addressed with the configurability in terms of RF data rate and power, one design can work for a number of applications. And it's been interesting to me, the number of customers that we have, that they really weren't sure how much RF data rate they needed. And so they've been able to look at it and say, well, does it work at 38.4 kilobits? No, that's not enough. Then I'll bump it up to 115 too. But they have the ability to play with that, and they also gives them some future proofing with the higher data rates of 200 kilobits per second and 500 kilobits per second to add more features and functionality. We say the application is moderately cost sensitive. I mean, this is a great value radio, quite honestly. But we have some radios that are even lower, lower price point. So we say moderately cost sensitive. And then obviously if you're having a sensor application, the ability to handle the analog or digital I/O is a real key feature. You can run these on battery. You're not going to get years on a battery with the big D&Ts, but you will get months. And then where you need large networks. So those are some of the keys to look for when talking to people about what radio. So why do the D&Ts win? And they win because they outperform radios that are much more expensive. And they outperform them in terms of the power, the adjustable data rates, the encryption, and this tree routing. They win because they're available on both 900 megahertz and 2.4. A lot of people think that, believe that 900 megahertz will go farther, and they're right to an extent. But if they want to sell internationally, they need 2.4 gigahertz. So this is one platform, and they can decide what radio to use depending on where they want to sell it. And then the networking features that we have. We have a TDMA, a time division multiple access scheme, where every remote gets the same amount of bandwidth, and that's limited to 16 remotes, or this carrier sense multiple access. So this is the listen before talk mode, similar to Ethernet, similar to Wi-Fi, and in this mode there's no limit to the number of remotes. We have heartbeats, where you can configure the radio to send a brief message saying that it's still part of the network, so that if a remote is only transmitting very infrequently, you can know more frequently that it's still there, and it's only not reporting because it hasn't asked to, as opposed to the fact that it's not reporting because it's left the network. We talked about the auto reporting, which is a key feature, really simplifies monitoring and sensing applications. The authentication gives you an additional level of security above the encryption. And then you get join and leave messages. So you have the ability to know when a node joins a network and when one leaves, which is a nice feature to have. Then with all the different things you can configure, the hop time, which is how long it stays on each frequency, the number of retries, because all of the error detection, correction, and retries are built into these radios. The ability to have co-located networks, subbands, we talked about that with the WITS, and then the analog and digital I/O, and then that it provides great value to customers while solving a lot of their problems. So the only two radios that really can give the DNT 900 and 2400 a run for the money are the DNT 90 and the DNT 24. So these are what we kind of call our little DNTs. And what you'll see is they're similar, but they're just a reduced feature set. And that reduced feature set lets us remove some costs from the radio and bring it out at a different price point. So the 900 megahertz is 100 kilobit per second over-the-air data rate. So that's the only data rate there is. It's not adjustable. And we go from 40 milliwatts up to 150 milliwatts. So we're not going to the 1 watt, but for a small, low-price radio, this is a high output power. And since a lot of people want the 900 for additional range, having this extra power can make a big difference. At the 2.4 version, it's a 250 kilobit per second. So why is it different? Well, there are a couple of reasons. One is that there's more bandwidth at 2.4, so you can have wider channels, get a little bit higher data rate, and still have a good frequency hopping performance. And then the 10 milliwatt to the 100 milliwatt, and the 100 milliwatt, like we said before, is for the international usage. Again, we have analog and digital I/O with UART and SPI-port. Has the auto reporting and sleep modes, and it has the encryption. It has the AS128 encryption. It doesn't have the authentication. All right, so that's one place where we're able to reduce the cost a little bit. These radios have store and forward repeating, so you can extend the network, but it's not as efficient as the free routing that the DNTs have. It does have a second diagnostic port. It has the unlimited number of remotes. It has a unique kind of combination between TDMA and CSMA mode, so there's no limit. And it's available with a chip antenna or the UFL antenna connector, and pinned or surface mount. And then the list price, $29, really setting a new price point for frequency hoppers with this type of performance. So the value proposition here is just everything you get at the price. So it's not strictly a price offering, even though it is a price leader. If you only looked at the price, it's a price leader, but when you start looking at the features and functions, it just blows the competition away. It truly does. So you'd want to look at the DNT, the little DNTs, again, frequency hopping performance. So you get the robustness and the immunity to interference. The application is very cost sensitive. So a list price of $29, you can put a lot of radios and a lot of different products at that price point. You need the analog and digital I/O. You want to have both the 900 megahertz and the 2.4 gigahertz in a drop-in replacement, and you're going to have some fairly large networks as well. The DNT 24 is new, so we've got to get the word out that it's out there, and we're working hard to do that. But we are seeing some good uptake on that in the early days as well. All right, so why do they win? So it's really the lowest cost frequency hopper out there, and you get it in both 2.4 and 900 megahertz. But even at a low price point, you still get some very sophisticated features in this, in terms of this TDMA CSMA mode, the heartbeats that we talked about to let you know if it's it's sleeping. It's sleeping. That's why it's not reporting. So it sends a heartbeat every once in a while. The auto reports, and then the join leave as well. Then we also have some specific sensing functions where we can do averaging. So when we're doing these auto reports, we can report the kind of the instantaneous value, or you can configure it to take a number of readings and only send the average value. And then we have adjustable scaling on the A to Ds that allow you to kind of zoom in at a particular level. So if you're interested in a temperature, let's say, but only when it gets above 50 degrees C, then when it gets above 50 degrees C, you don't care about reading less than 50 degrees C, so you can kind of adjust the scaling so you get more resolution between, say 50 degrees C and say 70 degrees C. So it's these were driven by some sensing customers that we have for the radios, and it's a very powerful feature. Again, what this does is it removes the need for coprocessors. These radios can be the only intelligence in these end devices. And you still have the same level of configurability with this common footprint. I'll talk about that a little bit more. And again, the bottom line is we're solving problems for our customers at a great and delivering great value. So now if we look at the whole DNT family, because it is sometimes a little bit confusing, we have our big ones, the DNT 900 and the 2400, and you can see the relative size, 1¼ by 2, and then our little ones, the DNT 90 and the DNT 24, which are 1 inch by just under 1.5 inches. So you can see the 900 megahertz, the difference in power, and the difference in maximum data rates, and same with the DNT 24 and the DNT 2400. So when we talk to people, if the DNT 90 or 24 will do what they need, then obviously that's the one we'll lead with due to the better price. But if they don't have, if they won't meet the need for whatever reason, we can then take them up to the DNT 900 and 2400, and we still have a very cost-effective radio solution to offer them. So looking at it more from the feature standpoint, I'm not going to go through all of these because you have this as a reference, but this just kind of shows a little, a more reduced feature set, a little more robust feature set. Here, the advantage is we've got different technologies in the same footprint. These, you don't have that, and then the price difference is important as well. So these are the last two slides really help you understand and position for your customers the difference between the big and the little DNTs. Okay, so here's our ZigBee Pro module. It's a ZPM 3570. It is a 100 milliwatt module, and you can adjust that over 20 dB. So you can adjust it down from 1 milliwatt up to 100 milliwatts. We expect to have the 1 milliwatt version coming out next month in January. We'll have a chip. We have a chip antenna here. The RF10 version will be a 1 milliwatt. 1 milliwatt will have chip or pin. So the pin allows you to take it to a different antenna style. We're currently supporting the ZigBee Pro Smart Energy 1.0 and the home automation profiles. Now the Smart Energy 2.0 is been approved, but it's still kind of in development. And so this is what the Smart Energy and the home automation require the ZigBee Pro stack. Now this module is very small, yet it still has 17 GPIO, and 5 of those can be analog. So very similar to what we've done in the past, analog and digital I/O. But it also has 1 megabyte of flash for data logging. So some of the devices in this smart energy profile, the requirement is that if the network link is lost because maybe power to a house went out or whatever, and this is battery operated, that you can store the data. All right, and so rather than have to have this off board, this is built onto the module and accessible through the module. So you don't have to have you typically will have a coprocessor with these ZigBee modules running whatever it is they're running, but the flash is already on the module. It has an API for host communication. So while some of our other modules that we talked about can be the only intelligence in a device, the ZigBee Pro, and this is not just our ZigBee Pro module, but basically ZigBee Pro as a technology, because of all the different types of end devices, you need something, another little processor to kind of run the specifics of whatever the ZigBee Pro device is. It's very small. You can see 27.2 by 14.7 millimeters, and it is approved FCC, Industry Canada, and CE, which is the Europe. And then the list price is $29.50. So again, very competitive product here. So the value proposition, and with the standard, the value propositions are going to be the same really across all ZigBee Pro modules, except that we've got this data logging flash in very small form factor. So this will be used when people need ZigBee Pro. Why will they need the ZigBee Pro? Because they're either going to be wanting to form ZigBee networks that are going to use smart energy or home automation, or, and this is maybe more often the case, where their device is going to become part of a pre-existing ZigBee Pro network. So the Smart Energy 1.0 and home automation interoperability, these are both public profiles in the ZigBee parlance, which means that they can interoperate with smart energy and home automation devices from other vendors. Where that data logging is required, and then low power sensing, low cost, and years of battery life. And these last three really are kind of the profile of ZigBee more so than any specific to our module. So why does it win? Again, the data logging flash, the small size, and the value that we provide. All right, so we're going pretty quick through this, but again, like I say, you'll have this this presentation. So now we're going to talk about our WSN, our WSN 802G, and this is a Wi-Fi module. It supports 1 to 11 megabit RF data rates. It's a 10 milliwatt module, and we call it B and G, which it is, but it will also compatible with N networks as well. So it will work with those access points. The key thing about this is that it can sleep. And the way it sleeps is it sleeps, but it sends very small messages, very similar to our heartbeats on some of our other modules, to keep the association with the access point active. So that means that when it wants to wake up and send data, it doesn't have to go through a 1 or 2 second reassociation. It simply wakes up, sends data, and then goes back to sleep. And the result of that is you get years on battery life. So it has the same auto-reporting that we talked about with our other modules, the same type of sleep in terms of timer, interrupt, and log value. And it has serial to Wi-Fi capability if you want to use the UART or the SPI. And when you're doing the serial through the UART, it's unformatted serial to Wi-Fi. There are a number of people out there with modules, and they say, yes, we do serial to Wi-Fi, but when you get into it, it's a formatted. So you have to change the format of your data to take advantage of their serial to Wi-Fi. When you're using our UART, whatever your application data is, that's all you need. You don't have to add any headers or checksums or anything else to it. It's unformatted serial to Wi-Fi, which is really, we have a number of people that when we tell them that, they go, really, boy, that's great. That's the key feature, because they'll have a legacy device that they want to attach Wi-Fi functionality to, and so they basically unplug the cable, plug in this module where that cable was connected, obviously in an embedded manner, and they're finished. That's all they've got to do. Years on battery life, again, because of the very slow sleep current and the fact that it doesn't have to reassociate every time it wakes up, but it does have an always-on mode. So you don't have to use it as a sleeping mode, sleeping node. You can use it always on. And in the always on mode, we have enterprise security. And so very few people have enterprise security in these modules. And this is the enterprise security that does, and I forget all the acronyms, but it does the certificate, and it does the supplicant, and it does the PEEP, and all the vegetable, the alphabet soup that you get into. So if people want to put something on, enterprise network where they've got all the security implemented, this is one of the few modules that will do it. Again, we talked about working on the B, G, and N networks, and the list price is $39, so it's very competitively priced there. So the value proposition here is it's a sleeping Wi-Fi, and it's also low power, which means that the peak current is such that you can run it off a AA alkaline. So the old notebooks that we used to have with the cards that would, the Wi-Fi cards that would draw so much current, this does not have that high peak current. So you're going to get I/O and years of battery life, and that allows you to take advantage of existing access points. So kind of the other half of the network is there. So you just have to worry about your nodes. You don't have to worry about a gateway or any other device to receive the data. You're going to take advantage of the existing access points. And you can have a wireless sensor node working on the same access point as someone's notebook computer. Okay, so it doesn't. There's no exclusivity required. It's just all Wi-Fi data going through there. So where it'll be used is where, like I say, the infrastructure already exists. You want battery operation, but you need Wi-Fi. Relatively high data rates required. It's 11 megabits. It doesn't try and do the higher 54 megabits and even higher of the N. But for the applications where you're going to be sleeping most of the time, waking up, sending brief amount of data, the 11 megabit is right where you want to go between the data rate and range. So let's see. So there's a question. I'm not sure there's any questions about concerns on the processor NOS. So one point I should mention here is that we have another product, a WLS, where you need drivers in the host processor. There really aren't any drivers here that are required. If we go back and look at this serial to Wi-Fi, that says you just send data to it. That's all you got to do. It's going to automatically join. You can configure it. You can configure it over the air. You can configure it through the serial port if you want to, but you don't really need the driver. So we don't worry about what the host processor is, because in many cases, let me back up here again, in many cases this is all the intelligence that's there. So we did a demo for a trade show where we took the module and we soldered a thermistor and a resistor directly to two pins in the module and had a wire hanging out for the antenna and then two AA batteries. And that was a complete wireless temperature sensor. And we talked to it, communicated to it through a standard access point and a standard notebook. So you don't need any other intelligence in these devices. But if you have it, that's fine. There's no driver needed. So you can use just a little 8-bit microcontroller to send data to this thing, because it's not going to have to handle all the Wi-Fi. All that is built into this module. All you got to do is send data through the serial port or wake it up through interrupts or whatever. So there is no concerns about a driver on this. There's a question about supporting USB, and we can support USB, but really what we do in that, and we do this on the development kit board, is by using like a Maxim USB chip. So what we do is we take that input, it's really at this end as a as a B device, a USB B device, kind of being a slave. Is what we're going to be getting is just the serial data. So at the other end, obviously you've got to worry about a driver for the USB. But at our end, what comes out of it really is just that we do the USB conversion. We've done it with FTDI, but there are others that you can use as well. So we're not going to put it on the module, and the reason we're not is because it increases size and cost. And if we had a customer that said, "Hey, I'm going to buy a boatload of these, but I need a version with the USB implemented on there," then we can certainly do that. But in terms of our standard product offering, this is being embedded, and so we're not seeing a universal demand for USB. But it's something we can add if we need it. Just finishing up, if you need serial to Wi-Fi or 802.11, and then again, if you want to avoid the coprocessor in sensing operations, and again that has both cost and battery implications by eliminating that that coprocessor. So where does this win? Well, it wins because it has the longest battery life, and it has more wireless sensor networking features in terms of the ability to wake up on timer, analog values, interrupts. It has the ability to, before it will wake up, it will activate one single line that will turn on, that can be used to turn on a sensor. to allow it time to settle out before it takes a reading, before it wakes up the radio. So again, it saves power that way. No coprocessors needed. No programming is needed either for the module or for a legacy device that wants to communicate with it. And it has the enterprise security. Then again, we have this common footprint. But again, at the end of the day, it's value that we're delivering, both through the features, the price, and the technical support. The LPR family, moving on, is our 802.15.4. So it's, like I said, the same radio technology as ZigBee, but without the mesh. They're available in 1 milliwatt and 100 milliwatt version, so low and high power. Chip antenna or an RF pinned, where you can plug it in, or surface mount. And then we have kind of our RFM networking layer in lieu of the ZigBee mesh layer with an API. But again, we have these auto reporting in sleep, very similar to the other modules that we've talked about. And here we have something that's very unique. It's a one-hop relay. So with 802.15.4, it's a direct sequence radio. So it does pretty good against multipath, but you can find that you can get in a multipath null. And while one node can hear another node, it can't hear the base station. So what this radio can do is it can send its data to the neighbor that it can hear, who will then relay it on to the base station. And what we found is that in an outdoor application with a lot of cars coming and going, where we had about an 85% reliability, when we added the one-hop relay, that went up into the very high 90%. So we have, real-life experience that shows how valuable this is. Excuse me. We also have the heartbeats, as we talked about before, so that if you have a sleeping node, you know it's still there. And again, with sleeping nodes, the auto reporting is so key, because if a node is asleep, how do you know when to poll it? And you can do it, but it means you have to wake the node up, keep the node awake, then transact the business, and what it does is it sucks all of your battery life out. So between the one-hop relay, the heartbeats, and the auto reporting, it really makes the sleep very effective, translating into long battery life. Again, we've got the encryption. We have 6 GPIO, 3 analog inputs, 2 analog outputs. Again, it comes with fully functional firmware. We have had some customers that have written their own firmware for this module, so we will support that. But more often what happens is customers will approach us about writing their own firmware, and we'll ask them, well, why do you want to do that? And when they explain what they're trying to do, the radio already does that. And so we say, hey, look, you can already do that. You don't need to write the firmware for it. So that's a very popular response to, kind of write your own firmware, and then you find out, well, it will do it. So a lot of them, with their limited functionality, doesn't do it. And the prices are very, very low and very competitive. Again, this is a standards-based module, so you're going to have other people out there with similar hardware, but it's the firmware, again, that really sets us apart. So again, this is your low cost. This is the 15.4 value proposition. Low cost, low power radio without the complexity of mesh. The mesh adds latency and network complexity. And really, I would say 80% of the people that come to us asking for ZigBee, once we talk to them, they really just need the 15.4, so they'll actually use the LPR 2430 family rather than the ZigBee. All right, so it's low power sensing, but not the mesh. Again, it's going to be, sensing or data, either one, at a low cost. Years of battery life. Again, the ability to avoid a coprocessor, keeping the battery power consumption down and the cost down. And then that one-hop relay alleviates the concern about any temporary obstructions or moving equipment that might cause a multipath null to form. So the LPRs win because we have more of these functions that we talked about. We talked about the heartbeats, again, the join leave messages. It's amazing to me the number of people, technologies out there, that the way you know a node is there that responds to you or doesn't respond to you, and this is an affirmative join and leave message. Chip antenna, UFL connectors, pinned surface mount, and then again our common footprint that we have. All right, so now going on to the XDM 2510, and it's WirelessHart. And WirelessHart is a standard. There's a Heart Communications Foundation, and it's also an IEC standard, and it's focused on process automation. Now, it's not the only place it could be used, but that was why it was developed. We have some customers that are using it in non-process automation applications due to some of the unique features it has. It's actually a 15.4 MAC and physical layer radio. But what it does, or excuse me, physical layer, the MAC is different. 15.4 has 15 channels. So what WirelessHart does is it takes this 15.4 radio and it changes channels all the time, every 10 milliseconds. So it looks just like a hopper. So it's basically kind of a channel hopping 15.4 radio. This is the only module outside of what you can get from Dust that uses the Dust Networks system on a chip. And Dust Networks invented this what they call time synchronized mesh protocol that WirelessHart is based on. So like I said, it's a frequency hopping 15.4, and what that does is it gives you frequency diversity, then coupled with their mesh gives you path diversity. So you're able to get by with a relatively low power radio, but because you're changing frequency and you have multiple paths, you get very high reliability at very low current consumption. It also supports sleeping routers, and this is where we get into some of the non-process automation applications. Is pretty much all the meshes, they do one of two things. Either you have to have the routers awake all the time, or you wake an entire network up periodically when someone needs to transmit and the whole network goes back to sleep. Well, both of those are very inefficient and don't lend themselves well to long battery life. What WirelessHart does is it tells each node when it can send data, but it also tells it when another node can use it for a router. So all the transmissions are very tightly scheduled. So a node that's asleep will wake up just before, and I mean a few bit times before, it can expect a transmission from another node that it needs to route. It only waits a couple of bit times after the signal should have arrived before deciding, hey, it's not sending me anything, I'm going back to sleep. So what it does is it allows you to have a completely, totally battery-operated mesh, and this is a true mesh. So any node can route data, and all of them can be battery-powered, and that's one of the key attractions to it, whether it's process automation or something else. You don't have to have, you can have battery-operated. Other meshes, you have battery-operated nodes at the edge, but then you have to power all your routers, and it just kind of breaks the economic module. It is a serial port only device, and part of that is because WirelessHart has a protocol that has to be followed. We have it available in pin and surface mount as usual, chip antenna, UFL, and you see the list price at $109. It's fairly expensive, and part of that is due to the fact that it has some very tightly controlled crystals in there to keep this timing. And then it also requires a gateway that's going to be like a $1,500 gateway that keeps track of all these, assigns all the times and stuff like that. So it's a little bit more of an upfront capital investment, but by having everything battery powered and having years of battery life, you gain the price advantage or the cost advantage in kind of total cost of ownership. So the value proposition here is a very high reliability with redundancy through this frequency hopping and these redundant mesh paths that everybody all nodes can run off battery, for years. So the nice thing about WirelessHart is most people will come and ask you for it. So they'll come up and say, hey, do you have WirelessHart? And you say, yes, we do. Sometimes they won't. Sometimes if it's a non-process automation application, they'll say, hey, I need a mesh where every node is battery powered. And you say, well, we've got that. We've got WirelessHart, and that will do it. They don't have to implement all of the WirelessHart commands. They can use just what they need to. So use it when high-value data is being sent. That's what process automation is doing, really. They're sending process variables that, if not monitored, could cause batches to be ruined, and that can be worth tens or hundreds of thousands of dollars. And then where you want that redundancy is being important as well. So this is a higher end. You'll see you'll see some opportunities for WirelessHart, but the nice thing is most of them are going to ask you for it directly. And so where does it win? Sleeping battery-powered routers. That's really the number one thing about it. You get the robustness due to the frequency hopping, but you also get the path diversity. And then Dust only supports the largest customers, so the Emersons and the Honeywells, people like that. But there are over 250 companies that make HART devices, and they're going to want to add this wireless capability, and Dust can't support many customers. They're not very good at support at all, quite honestly. Great technology, innovators, but they're not good at support customers, so they limit themselves to just the largest customers, and Dust refers people to us. And so when we say smaller customers are kind of the 50 to 100,000 unit per year customers, which is nice business for a module that even at those volumes is going to be in kind of the $50 range. And then again, it's our common footprint, and I got a slide on that I'll talk about next. So we do have on these different modules basically the same pinout and the same footprint. So where you have a WSN 802G, you can mechanically and electrically plug in our LPR 2430 802.15.4 or our WirelessHart or our DNT90 or our DNT24. So what it does is it gives a lot of flexibility to customers where they can have one hardware platform but support multiple RF technologies. So it's it's a comfort factor that customers can hedge their bets when they just pick a wireless technology. If the market goes a different direction, hey, they've got a solution that they can go to. All right, so these are talk a little bit about some of the sales support tools that we have for you. And on all these modules, we've got what we call our little tip sheets. And these are not really for customers, they're for you. And so what they're designed to do is to give you at your fingertips a single page that'll give you a bit of an overview of the product, the top features and benefits, the competitive advantages, and then just give you an idea of some of the markets and applications. So ideally, because we have so many different module technologies, trying to keep them straight, these are just a simple way to have at your fingers, what the module does, and like I say, competitive advantages and features and benefits. So we've got some pretty good feedback on these so far. That it's a nice, handy sales tool without having to flip through manuals or catalogs. The other collateral that we do have, we have brochures, which this would be. This is for potential customers, where this is really for your own end use, your own use. We have data sheets, we have the integration guides, and of course we have the website. And the tip sheets aren't, but all these other devices, all these other collateral pieces are available to our customers, to your customers, through the website without having to register on the website. So if they want to know more about the DNT24, they can download the integration guide, which defines all the modes of operation, the API, the whole bit, and they can do it without signing up on the website. All right, well, that is what I have. I think we kind of kept it to about about an hour. It's a lot of information, but again, you will have this presentation available as a reference in addition to the tip sheets.